Okay, so I'm going to be going through my presentation here really quick. Let me start this. All right. So we're going to be talking today about the strategies for engineering quality software. This is coming from a computer ethics book. And it's important everyone here understand the importance of developing high quality software because we're all in industry similar to that, and we don't want to be putting out bad software. So without further ado, here we go. So in order to understand how we're going to engineer high quality software, we have to understand kind of what software quality is. Straight from the book, software quality is the degree to which a software product meets the needs of its users. So when we get a requirement document and we know our customers want software to do X, Y, and Z, in order for us to have high quality software, we need to meet those needs. There's also other attributes to having high quality software that we need to look at. These are straight out of the book, and there's kind of important pillars to think of when you're thinking of high quality software. So they want to perform quickly and efficiently. You want to obviously meet the user's needs. You want it to be safe and reliable, and you want to keep downtime to a minimum. So, you might have software that really, meets the user's needs and in theory is going to do everything the users want. But if they have a bug where it's going to crash every 15 minutes, that's not going to be high quality software. So it's important to kind of keep those pillars in mind when we talk about engineering high quality software. It's also important to note that because computers are becoming a bigger and bigger part of every single industry and of the world, and they're kind of running, they're the backbone to a lot of mission critical systems for our everyday life. So the demand obviously is going to increase, and so it's more important than ever to have high quality software because we depend on that software more and more. If that makes sense. So going on, we're going to talk a little bit about maybe the more poor quality software and kind of the other end of the spectrum. So we have to look at what a software defect is, and that's any error that, if not removed, could cause a system to fail to meet its user's needs. So basically anything in software, any bug, any design flaw that's going to cause our software to not do what the customer wants. We'll kind of talk a little bit more about this idea when we talk about misrepresentation or intentional misrepresentation. Another really important idea to understand, and this is kind of a principle that's used in a lot of software development companies, is the idea of quality management. So it focuses on kind of setting, defining, measuring, and refining the quality of the development process at the various stages. And why this is important is because it puts these steps in place so that we aren't putting out poor quality software. And so, we have an idea of the quality of our software before we release it. And again, that's really important. We'll talk about that a little bit later with quality assurance, but all this includes, requirements, flowcharts, documentation. It's all stuff that, isn't the actual software, but is important to include when we're delivering the software. A lot of times poor quality software just comes from having poor practices. Developers aren't perfect. So, they might have fundamental design flaws. There might be issues in, documentation of the code or of security, and, all these, there's, plethora of things that can contribute to bad code. And a lot of it stems from developers just having poor practices. Also, lack of proper time allocation. A lot of times there's simply pressure to be put on developers to put a product out before it's ready. And so they're not going to put enough time into it to, recheck the code and really go through the testing procedures as much as they should to ensure that they have high quality software. And so, it's unfortunate, but those are both things that kind of contribute to poor quality software. Cool quote from the book that I thought kind of demonstrates this a little bit. The developers are not incompetent or lazy. They're just human. And customers are the key stakeholders. And so we have to come back to the idea that if a customer's needs aren't met, then the software can't be considered high quality. It's not possible. And so that's kind of the first thing when you're developing software you want to look at. Does this software meet my customer's needs? And then from there, we look at these other merits of high quality software to ensure they're high quality. Just one more little quote from the book. This was actually right in the front of the chapter. It says, a little unknown author quote, "It's not a bug, it's an undocumented feature." I just thought that was kind of funny because, when we look at software packages, like the book talks a little bit about Windows Vista and how it's, hundreds of thousands of lines of code. It's this massive software package. Even if it was 99.9% percent bug free, there's still going to be tons of bugs. And so it's kind of, you have to let customers drive features and development, but you also have to realize that the larger the software project, the more chances there are going to be for bugs and errors, and you just have to minimize those wherever you can. Talk about the importance of software quality in a few industries and a few applications. And so there's these two ideas the book brings up: business information systems and decision support systems. And these are both, mission critical parts to a lot of businesses, and they have to be of high quality and reliable, kind of like we talked about over on that first slide, those pillars of high quality software. It's all important here. So a business information system is a set of interrelated components, including hardware, software, databases, network, people, and procedures, that collects and processes data and disseminates the output. So just a few examples, point of sale systems, air traffic control systems, SAP, just anything that's, the core of a business, and it involves so many different moving parts. And a lot of times at the core of that is important software. And, we see when we talk about, liabilities and the importance of that, little issues in a business information system can cause, catastrophic meltdowns for an entire industry. So it's really important that software is of high quality. We also have decision support systems, which are used to improve decision making in a variety of industries, straight from the book. So some examples would be like forecasting customer demand, recommend stocks and bonds, schedule shift workers in a way which maximizes profits. So these are all things that, I would go to the software application and would say, hey, you should invest in this stock because we have these crazy algorithms that predict it's gonna increase, and you're gonna make tons of money. And that's really awesome. It's a really cool idea for software. But again, quality becomes super important here, because if there's a mistake in this code, if there's something wrong with it, there's inherent flaws in the software that makes it not high quality software. You can mess up huge companies and like really damage them. If we're looking at military or government software, or air traffic control, or financial services use a lot. Financial services is a big industry for decision support systems, and if they mess up there, you can talk about catastrophic consequences that would result. So that's really important to think about these massive systems when we're talking about software quality. Software product liability is also important. And basically it's, to run through this quickly, if you've taken B-Law, it's basically, what you learned in there. But there's tons of, possibilities for things to go wrong, especially with software. So, the book talks a little bit about like, financial meltdowns, plane crashes, car accidents that all stem from faulty software. So we look at product liability, basically the liability that the makers of the software have when an injury is caused by their product being defective. And then we have these definitions for strict liability and negligence. You basically, I'm sure you've all learned this in previous classes, but it's that you're responsible for your product, regardless of negligence or intent. If the product does something that hurts other people, you're going to be in trouble. And negligence is if you like mess up in a way that wouldn't be considered reasonable. So it's really important to kind of think of this when you're developing software, especially when you're talking about larger, more mission critical systems and important software packages. I've talked a little about intentional misrepresentation. This is a big one, especially when we're talking about ethics. It's when a seller or lessor either misrepresents the quality of a product or conceals a defect in it. And basically, this is common sense, but I'm going to say it because it's an ethics class. It would not be ethical to lie about what your software does or lie about problems the software has. You do this and you're probably going to get sued for intentional misrepresentation or fraud. It's just bad. And, we talked, I think actually the first day of class, Pam discussed, you don't want to lie or be, misrepresent your product when you're trying to sell it. That's a big no-no. And again, kind of like what we talked about in the previous slide, this could end up getting people hurt, especially if you're talking about safety or reliability functions of the software. Warranties, we really don't need to spend that much time talking about this, but basically, especially with larger software packages, there's often, some kind of warranty that basically says software is going to do what we say it's going to do. There's this whole list of things that your product must meet in order to be warranted. And this is pretty much straight out of B-Law. And basically, if you fail to meet the terms of warranty, you are in breach of the warranty. So, like I said, this really doesn't apply to smaller software packages, because most of the smaller software packages, the consumer-facing stuff, is going to have something in the terms and conditions that says this product is not under warranty. But if you're talking, larger systems, stuff running financial markets, the stuff running airplanes, that's going to be warranted. A little bit about the software development process. According to the book, basically there's the software development methodologies, which is the entire process and standard that a company has to control development of high quality software. And so it's basically their workflows. You start working at a company that's developing software, and they're going to train you in this, and then they know that everyone who's developing software for them is developing it in the same way. So that's pretty cool. And a big one here is the agile development process. It's kind of a newer one, not newer, but it's really catching on. If any of you have taken software engineering, you know all about that. And then the idea of quality assurance, which I alluded to earlier, is referring to methods within. So it's basically in your development cycle, there's steps that are going to be checking the software, and a lot of that is in testing. It's just so that we can say, as a company, we have these policies and these testing procedures in place to ensure that we release high quality software. And it's kind of like covering your back, but also you want to make sure that you're releasing high quality software. A little bit about testing. I know we're running a little short on time, so I'm gonna make this fast. Basically, there's tons of testing. Two big ones are black box testing and white box testing. Black box is where the test doesn't get to see the inner workings of the software, the code, and can't really mess with any internals. White box testing, it's all transparent. Differences are really, like user case testing and kind of user experience testing for black box. And white box is more like we want to check to make sure that this part of the application, this part of the software is talking to this part of the software correctly, and we're not having any issues there. And that kind of helps kill a lot of bugs. And you can look up, there's all these tons of types of testing and testing platforms, and they're all great for different applications. Capability, maturity, model, integration. This is the last little section of the book. It's a pretty simple concept. Basically, there's these levels of maturity that software can be classified as. From the top to the bottom is kind of young, not as good software, and when you get down to optimizing, you have a strong software product, and you're really just fine tuning it. And this is a quick survey that was done, 5,000 different organizations. Basically, where is your software at in this model? Most of them landed in defined. I guess that's fine. It's up to you whether or not you think everything should be optimized. But the goal is obviously to be as low on that scale as possible. But it's just a little interesting numbers. Does anyone have any questions or comments? Cool. So that's pretty much it for this talk. Thank you.